The National Electrical Code, or NEC, specifies the maximum allowable load for a main breaker or fuse switch, often abbreviated as FSS. The answer to this question is no. You cannot load a main breaker or fuse switch to 100% of its rating. The code mandates that these devices are only loaded to a maximum of 80%. This 80% rule is in place for crucial safety and operational reasons. Let's delve deeper into the reasoning behind this requirement. The primary reason for limiting the load on a main breaker or fuse switch to 80% is to prevent overheating and nuisance trapping. Electrical conductors, breakers, and fuse switches all generate heat when carrying current. The amount of heat generated is proportional to the square of the current. If a breaker or fuse switch is continuously loaded at 100% of its rating, the excessive heat buildup can lead to several problems. Firstly, the insulation surrounding the conductors can degrade over time, potentially causing short circuits or ground faults. Secondly, the breaker or fuse switch itself can overheat, leading to premature failure or even a fire hazard. Thirdly, the breaker may trip unnecessarily, interrupting power to the connected loads. The 80% rule provides a safety margin to prevent these issues from occurring. By limiting the load to 80%, the amount of heat generated is significantly reduced, minimizing the risk of overheating and ensuring the long-term reliability of the electrical system. Now let's consider some specific examples to illustrate the application of the 80% rule. Suppose you have a 200 amp main breaker. According to the NEC, the maximum continuous load that can be connected to this breaker is 80% of 200 amps, which is 160 amps. Similarly, if you have a 100 amp fuse switch, the maximum continuous load should not exceed 80 amps. It's important to note that the 80% rule applies to continuous loads. A continuous load is defined as a load that operates for 3 hours or more at a time. Examples of continuous loads include lighting, heating, and air conditioning systems. Non-continuous loads, such as appliances that are only used for short periods, are not subject to the same restriction. However, it is still good practice to avoid overloading the main breaker or fuse switch, even with non-continuous loads. To ensure compliance with the 80% rule, it is essential to perform a load calculation. A load calculation is a process of determining the total electrical demand of a building or electrical system. The load calculation takes into account all of the connected loads, including lighting, appliances, and equipment. The calculated load is then compared to the rating of the main breaker or fuse switch to ensure that it does not exceed the 80% limit. The NEC provides detailed guidelines for performing load calculations. These guidelines specify the demand factors that should be used for different types of loads. A demand factor is a multiplier that is applied to the connected load to account for the fact that not all loads will be operating at their maximum capacity simultaneously. For example, the demand factor for general lighting in a dwelling unit is typically 0.35, meaning that only 35% of the connected lighting load is assumed to be operating at any given time. By using demand factors, the load calculation provides a more realistic estimate of the actual electrical demand. It's important to remember that the 80% rule is a minimum requirement. In some cases, it may be necessary to further reduce the load on the main breaker or fuse switch to ensure adequate safety and reliability. For example, if the ambient temperature is high, the breaker or fuse switch may need to be derated to account for the increased heat. Similarly, if the breaker or fuse switch is located in a poorly ventilated area, it may also need to be derated. Derating is the process of reducing the ampacity of a conductor or overcurrent protective device to account for factors such as ambient temperature, conduit fill, or voltage drop. The NEC provides tables and formulas for determining the appropriate derating factors. In addition to the 80% rule, the NEC also specifies other requirements for the installation and protection of main breakers and fuse switches. These requirements include proper sizing of conductors, grounding, and overcurrent protection. Conductors must be sized to carry the calculated load current without overheating. The NEC provides tables that specify the ampacity of different types of conductors based on their size, insulation type, and installation method. Grounding is essential for providing a safe path for fault current to flow back to the source. The grounding system must be properly installed and maintained to prevent electrical shock hazards. Overcurrent protection, such as circuit breakers and fuses, is required to protect conductors and equipment from overload and short circuit conditions. The overcurrent protection device must be sized to protect the conductors and equipment it serves. It's also important to ensure that the main breaker or fuse switch is properly maintained. This includes regular inspection and testing to ensure that it is operating correctly. Breakers should be tested periodically to verify that they trip within the specified time current characteristics. Fuses should be inspected to ensure that they are not damaged or deteriorated. Any damaged or defective component should be replaced immediately. In summary, the 80% rule for main breakers and fuse switches is a critical safety requirement of the NEC. It is designed to prevent overheating, nuisance tripping, and other problems that can arise from overloading electrical equipment. By following the 80% rule and other applicable NEC requirements, you can ensure the safe and reliable operation of your electrical system. Remember to always consult with a qualified electrician for any electrical work to ensure that it is performed safely and in accordance with all applicable codes and regulations. The 80% rule discussed here is not just an arbitrary number. It's rooted in engineering principles and practical experience. The rule addresses the thermal limits of the equipment and conductors involved. When electrical current flows through a conductor, it generates heat due to the conductor's resistance. This heat is proportional to the square of the current, as dictated by Joule's law. If the current exceeds the conductor's ampacity, the heat generated can damage the insulation and potentially cause a fire. Circuit breakers and fuse switches are designed to protect conductors from overcurrent conditions. However, they too have thermal limits. When a breaker or fuse carries current, it also generates heat. If the heat exceeds the device's thermal capacity, it can trip prematurely or even fail. The 80% rule helps to ensure that the heat generated by the current flow remains within the safe operating limits of the conductors and overcurrent protection devices. The National Electrical Code is a comprehensive set of standards for the safe installation of electrical wiring and equipment. It is updated every 3 years to reflect the latest technological advancements and safety practices. The NEC is not a law itself, but it is widely adopted by state and local jurisdictions as the basis for their electrical codes. Compliance with the NEC is essential for ensuring the safety of people and property. Here are some additional considerations related to the 80% rule. Firstly, the 80% rule applies to the total continuous load connected to the breaker or fuse switch. This includes all loads that are expected to operate for 3 hours or more at a time. Secondly, the 80% rule does not apply to non-continuous loads. However, it is still important to avoid overloading the breaker or fuse switch with non-continuous loads. Thirdly, the 80% rule is a minimum requirement. In some cases, it may be necessary to further reduce the load on the breaker or fuse switch to ensure adequate safety and reliability. Fourthly, the 80% rule is just one of many factors to consider when sizing electrical equipment. Other factors include ambient temperature, conduit fill, and voltage drop. Fifthly, it is always best to consult with a qualified electrician for any electrical work to ensure that it is performed safely and in accordance with all applicable codes and regulations. Finally, the specific sections of the NEC that address the 80% rule may vary depending on the year of the code and the specific application. It is important to consult the latest edition of the NEC and to understand the specific requirements that apply to your situation. Now let's explore how the 80% rule impacts load calculations in practical scenarios. Imagine a small retail store. The store has lighting, receptacles for general use, a small HVAC system, and a few pieces of equipment such as cash registers and computers. To determine the appropriate size for the main breaker, a load calculation must be performed. Firstly, determine the lighting load. Measure the total wattage of all the lighting fixtures. Apply a demand factor if applicable. The NEC allows for demand factors to be applied to lighting loads in certain situations. Secondly, calculate the receptacle load. Assume a certain wattage per receptacle, as specified by the NEC. Apply a demand factor if applicable. Thirdly, determine the HVAC load. Obtain the nameplate rating of the HVAC equipment. This will typically be expressed in amps or kilowatts. Fourthly, determine the equipment load. Obtain the nameplate ratings of all the other equipment in the store, such as cash registers and computers. Fifthly, sum all of the individual loads to obtain the total connected load. Sixthly, identify any continuous loads. A continuous load is a load that is expected to operate for 3 hours or more at a time. Seventhly, apply the 80% rule to the continuous loads. Multiply the continuous loads by 1.25. This is the same as dividing by 0.80. Eighthly, add the non-continuous loads to the adjusted continuous loads to obtain the total calculated load. Ninthly, select a main breaker that is rated to carry the total calculated load. The breaker should be sized to at least 125% of the continuous load plus 100% of the non-continuous load. This ensures that the breaker will not trip unnecessarily due to overload. The NEC provides detailed guidelines for performing load calculations. These guidelines specify the demand factors that should be used for different types of loads. Demand factors are based on statistical data and reflect the fact that not all loads will be operating at their maximum capacity simultaneously. Using demand factors can significantly reduce the size of the main breaker required, which can save money on equipment costs. However, it is important to use demand factors appropriately and to ensure that the calculated load is still sufficient to meet the actual needs of the building. In addition to the 80% rule, there are other factors that can affect the sizing of electrical equipment. One such factor is voltage drop. Voltage drop is the decrease in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC specifies maximum allowable voltage drop for different types of circuits. To minimize voltage drop, conductors should be sized appropriately for the length of the run and the amount of current they are carrying. Another factor to consider is ambient temperature. The ampacity of a conductor decreases as the ambient temperature increases. This is because the conductor's insulation becomes less effective at dissipating heat at higher temperatures. The NEC provides tables that specify the ampacity of conductors at different ambient temperatures. When selecting conductors, it is important to choose a conductor with an ampacity that is sufficient for the load and the ambient temperature. Conduit fill is another factor that can affect the ampacity of conductors. When multiple conductors are installed in a conduit, the heat generated by each conductor can raise the temperature inside the conduit. This can reduce the ampacity of the conductors. The NEC specifies maximum allowable conduit fill percentages for different types of conduits. When installing conductors in the conduit, it is important to ensure that the conduit is not overfilled. This will help to prevent overheating and ensure that the conductors can carry their rated current. The 80% rule is an important safety measure that helps to prevent overheating and nuisance tripping of circuit breakers and fuse switches. By following the 80% rule and other applicable NEC requirements, you can ensure the safe and reliable operation of your electrical system. Remember to always consult with a qualified electrician for any electrical work to ensure that it is performed safely and in accordance with all applicable codes and regulations.